Hi, I hope that this video finds you doing well. If you're like me, it's been a pretty busy week, and I want to apologize for being later this week getting this video completed. Today, we're going to look at sections 3.2 and 3.4, and we'll be looking at synthetic division. So let's get started. Number one, ask us to use synthetic division to perform our division problem. So we have 5x cubed plus 6x plus 8 divided by x plus 2. When we use synthetic division in the numerator, we have to have our powers in descending order, and we can't be missing any powers. So notice here we're missing the x squared. What we do then is we fill in a 0 for that missing power, because 0 times anything is 0, so we haven't changed the problem. And now my powers in the numerator go 3, 2, 1, and my constant, which doesn't have an x. With synthetic division in the denominator, you either have to have an x plus a number or an x minus a number, and here we do. We take the opposite of what's in the denominator. So here we have x plus 2. We're going to take the opposite of that, and we're going to put the negative 2 in the box. Then list your coefficients. In front of the x cubed is 5. In front of the x squared is 0, in front of the x is 6, and then our constant is 8. We bring down that first number, so I bring down the 5. Then I say 5 times the number in the box. So 5 times negative 2 is negative 10, and I add that to the next column. 0 plus negative 10 is negative 10. Then I take this negative 10 and I multiply times the box again. So negative 10 times negative 2 is a positive 20. And I'm going to add the 20 to the next column. 6 plus 20 is 26. Again, I take the number down here, 26, and I multiply times the box, times negative 2. 26 times negative 2 is negative 52. And I add that to this next column. 8 plus negative 52 is negative 44. Now, I always put that last number in the box because the last number is my remainder. As I get ready to write my answer, I'm going to bring down that 5, and I have an x, and I need to decide on the power of x. We always use one less power than what we started with. So we started with an x cubed, and one less power would be x squared. Then our powers decrease, so then we have a negative 10x, or x to the first, and then the constant. Then we take that remainder, so minus and 44, and we put it over the denominator of our fraction, so x plus 2. And that's our final answer. Let's look at number 2. In number 2, we have our function 3x cubed plus 4x squared minus 5x plus 3. And here, k is negative 4. And we're asked to find f of k. Now, typically, if we're finding f of k, or here, f of negative 4, we would take that negative 4 and plug it in place of x everywhere. But our problem asks us to use synthetic division. So what we do is we look at our powers. Our powers in our function are in decreasing order, and no powers are missing. We have the x cubed, the x squared, x to the first, and then the constant. I put the negative 4 in the box. Now notice here, I do not take the opposite of it because I didn't have x plus a number or x minus a number. That's the only time I take the opposite. Bring down your coefficients. So we have a 3 in front of the x cubed, a 4 in front of the x squared, a negative 5 in front of the x, and our constant is 3. Bring down the first number, so bring down the 3. 3 times negative 4 is negative 12. And I add that to the next column. 4 plus negative 12 is negative 8. Then I take this negative 8 and I multiply times negative 4. Negative 8 times negative 4 is positive 32. Add that to the next column. Negative 5 plus 32 is 27. Multiply 27 times negative 4 times the box. And that's going to give me negative 108, I believe. and then add to the next column gives us negative 105. This 105 or negative 105 is my f of k. And so my answer here, f of negative 4, would be negative 105. Now look at number 3. We have two parts to number 3. Part A has f of x is 2x cubed minus 3x squared minus 11x and plus 6. And we have k is 3. We are asked here to decide whether k is a 0 of our polynomial and then to give a reason why or why not. So again, we're going to use synthetic division. The first thing I need to look at is my function. Are my powers in descending order? Yes. Am I missing any powers? No. My powers go x cubed, x squared, x to the first, and then a constant. Put the 3 in the box. Again, I don't take the opposite of that because I don't have x plus 3 or x minus 3. And we list our coefficients. In front of the x cubed is 2. In front of the x squared is negative 3. In front of the x is negative 11. And then we have 6 at the end. Bring down the 2. 2 times 3 is 6. And we add that to the next column. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 11 plus 9 is negative 2. Multiply negative 2 times 3 is negative 6. And 6 plus negative 6 is 0. We look at this remainder. And if the remainder is 0, then our k value here, 3, is a 0 of the polynomial. So yes, 3 is a 0 of the polynomial. Because the remainder is 0. So let's look at part B. So part B, we have f of x is 15x cubed plus 14x squared minus 3x plus 2. And we have k equals negative 1. I'm actually going to change that just a little bit from what I sent you. I'm going to make that k negative 1 plus I. Again, I'm going to use synthetic division. So are my powers in decreasing order? The answer is yes. Am I missing any powers? The answer is no. I put the negative 1 plus I in the box, and I'm going to list my coefficients. Now this time, because of the I, notice that I'm leaving a little bit more space in between each of my coefficients. Bring down that 15. Then what I do is I say 15 times the number in the box. So I'm going to distribute that 15. When I distribute the 15, that gives me negative 15 and plus 15i. And I add this to the next column. When I add that to the next column, then I add my like terms. 14 plus negative 15 is negative 1, and bring down that 15i. And now I multiply negative 1 plus 15i times negative 1 plus I. So I have to use FOIL here to multiply. My first term is 1. My outer is negative I. The inner is negative 15i. And the last would be 15i squared. So I bring down the 1. Put your like terms together. That gives us negative 16i. Remember, I squared is negative 1. So 15 times negative 1 is negative 15. We still have like terms. 1 minus 15 is negative 14. And bring down the negative 16i. Add this to that next column. So I'm adding negative 14 minus 16i. Add your like terms. Negative 3 plus negative 14 is negative 17, and bring down that minus 16i. Again, I take my number, negative 17 minus 16i, and I multiply times the box. So my box, or my k value here, was negative 1 plus I. Use FOIL again. Negative 17 times negative 1 is positive 17. Negative 17 times I is negative 17i. That's my outer. My inner, negative 16i times negative 1 is a positive 16i. And the last would be negative 16i squared. Bring down the 17 and put your like terms together. Negative 17i plus 16i is a negative I. Again, I squared is negative 1. Negative 16 times negative 1 is a positive 16. And once again, we still have like terms. 17 plus 16 is 33. And bring down the minus I. I'm going to add the 33 minus I to that last column. 2 plus 33 is 35, and bring down that minus I. Now, before I get to the answer, when you see a problem with the I's, just take your time with them and tell the students to take their time with those problems, because there's a lot of places to make some careless mistakes. I look at my remainder here. My question asked, is k a 0? My remainder is not 0. So here, negative 1 plus I is not a 0 of the polynomial. And my reason is because the remainder is not 0. Again, the problems with the I's are a little bit more difficult, and it's just because there are so many places to make some careless mistakes. All right, let's look at number 4. In part A, we have f of x is x cubed minus x minus 1, and we have two values here, an a and a b. And our problem asks us to decide whether or not there is a 0, a real 0, between a and b. Again, I'm going to use synthetic division. I notice that my polynomial is missing the x squared, so I'm going to fill in a 0 for that missing power and bring everything else down. And now my polynomial has my powers in descending order and without any missing powers. I'm going to use synthetic division twice here. So I'm going to start with my first value, which is 1, and bring down your coefficients. Bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Plus negative 1 is 0. 0 times 1 is 0. And negative 1 plus 0 is negative 1. Then I'm going to use synthetic division again, and I'll put the 2 in the box. List your coefficients and bring down that first coefficient. 1 times 2 is 2. Add that to the next column, gives us 2. 2 times 2 is 4. Negative 1 plus 4 is 3. 3 times 2 is 6. And negative 1 plus 6 is 5. When I'm trying to decide if there's a 0 between my two numbers, I look at my remainders. And notice that these remainders have opposite signs. So here, yes, there is a 0. Between 1 and 2, those were my a and b values. Because the remainders have opposite signs. So let's look at part B. Here we have f of x is 2x to the fourth minus 4x squared plus 1. Our a value is -3, and our b value is -2. Look at your polynomial. Notice that we're missing the x to the third, so I'm going to fill in a 0 for that x to the third. Bring down the minus 4x squared. We are also missing the x, so I'm going to fill in a 0x. And even if the problem is missing the constant, you would fill in a 0 for that constant as well. Here my constant is +1, so I brought that down. Put your first value in the box, so I put the -3 in the box, and list your coefficients. Bring down the 2. 2 times -3 is -6. 0 plus -6 is -6. -6 times -3 is 18. -4 plus 18 is 14. 14 times -3 is -42, I believe. 0 plus -42 is -42. -42 times -3 would be 126, and plus 1 is 127. Our next value is -2, so put your -2 in the box and list your coefficients. And use synthetic division again. So bring down the 2. 2 times -2 is -4, plus 0 is -4. -4 times -2 is 8, plus -4 is 4. 4 times -2 is -8. 0 plus -8 is -8. -8 times -2 is 16, and 1 plus 16 is 17. My problem asks me, is there a 0 between -2 and -3? So I look at my remainders. Notice here that the remainders have the same sign. And so no, there is not a 0. Between -2 and -3, because the remainders have the same sign. Now let's move to number 5. Number 5 asks about what's called the boundedness theorem. Every instructor may ask questions related to the boundedness theorem in a different way, so be sure that you talk to your instructor and see how they will ask questions about the boundedness theorem. Part A asks us, is 7 an upper bound? For the zeros. And we have our polynomial here, f of x equals x to the fourth minus 5x cubed plus 11x squared plus 33x and minus 18. Notice my polynomial function is not missing any powers, and my powers are in descending order. So I put my 7 in the box and I list my coefficients. We use synthetic division, so bring down the 1. 1 times 7 is 7. -5 plus 7 is 2. 2 times 7 is 14. 14 plus 11 is 25. $25 times 7 is 175, plus 33 would be 208, times 7 is 1,456, plus -18 is 1,438. So what I look for with an upper bound is I look at this bottom row of synthetic division. Now I'm going to look at all of these numbers on the bottom row. And if this is an upper bound, and an upper bound would mean no zeros greater than 7. And that might be a way that some instructors ask the question. That's the way that Math Labs will phrase it. So an upper bound means no zeros greater than 7. I look at that bottom row that I have highlighted in green. Are all the numbers positive? The answer is yes. And so 7 is an upper bound for the zeros. Of the polynomial because all the numbers on the bottom row and again, I'm looking at that bottom row there, are positive. And it's okay if one of those numbers happens to be 0. So look at part B. Part B asks us, is 1 an upper bound? And we have the polynomial x to the 4th plus 11x cubed minus 12x squared and minus 6. Notice that this polynomial is missing the x term, and so I need to fill in a 0 for that missing power. And so I fill in 0x. Put your 1 in the box and list your coefficients. Bring down the 1. 1 times 1 is 1, plus 11 is 12. 12 times 1 is 12, plus negative 12 is 0. 0 times 1 is 0, plus 0 is 0. 0 times 1 is 0, plus negative 6 is negative 6. Now notice here that we have a negative on the bottom row of that synthetic division. So here 1 is not an upper bound. For the zeros of the polynomial, because there is a negative on the bottom row of synthetic division. Now it just so happens that that negative is the remainder, but the negative doesn't have to be the remainder. If there's a negative anywhere on that bottom row, then 1 is not an upper bound, or what that tells me is there's a 0 that's greater than 1. So in other words, there is a 0 greater than 1. On part A, another way of looking at this upper bound is here, there is no 0 greater than 7. And that's just another way of saying an upper bound. Again, talk with your instructor to see how they're going to ask the question on the test. So let's move from looking at upper bounds to looking at lower bounds in part C. So part C asks us, is -1 a lower bound? And our polynomial here is x to the 4th minus 5x cubed plus 11x squared plus 33x and minus 18. When we think about a lower bound, what that's telling me is no 0 less than my number. And here would be no 0 less than -1. My polynomial function is not missing any powers. My powers are in descending order, so I put the -1 in the box and list my coefficients. And bring down the 1. 1 times -1 is -1. -5 plus -1 is -6. -6 times -1 is 6. 11 plus 6 is 17. 17 times -1 is -17. Plus 33 is 16. And 16 times -1 is -16. -18 plus -16 is -34. Again, when I'm thinking about the lower bound or the upper bound, I am looking at the bottom row of the synthetic division. So I'm looking at this right here. And I want to know, do my signs alternate back and forth between positive and negative? So notice here we have a positive, a negative, a positive, and then a positive. And so notice the signs don't alternate. So no, -1 is not a lower bound. For the zeros of the polynomial. Because the signs on the bottom row of synthetic division do not alternate. And so again, another way of looking at this is this. There is a 0 less than -1. Let's look at part D. So part D asks us, is -13 a lower bound? And again, when I'm thinking about that lower bound, what I'm thinking about is no 0 less than 13. And we have our polynomial. We have x to the 4th plus 11x cubed minus 12x squared and plus 6. Notice our polynomial is missing a power, so I fill in a 0 for that missing power. I put the -13 in the box, and I list my coefficients. My powers were in descending order, and after I added that 0 in, I wasn't missing a power. And use synthetic division. So bring down the 1. 1 times -13 is -13. 11 plus -13 is -2. Negative 2 times negative 13 is a positive 26. And when I add that to negative 12, I get 14. 14 times negative 13 would be negative 182. Add that to 0 is still negative 182. Times negative 13 gives me a positive 2,366. And when I add that to 6, I get 2,372. So I look at my signs along this bottom row of synthetic division. And notice here my signs are positive, negative, positive, negative, positive. So notice that the signs alternate. And so yes, negative 13 is a lower bound for the zeros of the polynomial. Because the signs on the bottom row of synthetic division alternate. And it's okay for the signs to start with a negative as long as the signs alternate back and forth between a positive and a negative. And so when we say that negative 13 is a lower bound, what that tells me is there is no zero less than negative 13. Well, I hope this helps you with sections 3.2 and 3.4. Next week, we'll look at section 3.3. Have a great rest of the week and a great weekend. Bye.